So I loaded this rotary test 3 function and I call it from here, from this loop function. Everything else is commented out, only this is activated. So this is the clock pin here, and it is assigned to Arduino pin on Arduino. So well, pretty much if this is changing, set this pin low. It means to turn on the red LED from the RGB. Is turning it on when it's low, because my RGB chip is weird. And when it's high, it's turned off. Here it should be off. So I actually copied this code from somewhere else and I've adapted it and it worked, but I will show you how it worked with some problems. So I program it through Arduino board there. I link it. So I link it through this in-circuit serial programmer jack or plug with this wire on pin 10 on the Arduino board. And now I'm powering it with 5 volts from there. I'm also having the oscilloscope on. If I'm turning on, let me actually put a little paper there to see that it's turning and how it's turning. Okay, good. So I have a marker here, this little paper marker that will actually show you how this device is rotating. So if I'm rotating it one step, randomly it is working. So you see, it's skipping a couple of steps, and randomly I have no idea when it's deciding to do it. If I'm doing it this way, you see, also randomly, you see. So you can follow this little white marker, and you can see if I'm turning it one time, is actually locking, like tuck, 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 is locking into whatever space is having inside. So it's having small steps that is actually locking on those steps when I'm turning from with my hand. You see, very precise markings. And sometimes it's not doing anything, it's not transmitting anything there, and sometimes it is transmitting. The signal is received and that LED is lighting up. And this is the behavior, you see. I have many turns to move this knob until it's actually lighting up that LED, which is very, it should lit up per each turn, per each segment. That is, you see, when I'm turning right now, it should lit up, and it did, but now it doesn't. But it should have. Now it does, now it doesn't. It doesn't, now it does, doesn't, does, and so on. You see, it's very random. It's very random. Doesn't matter in which sense I'm rotating it. See, sometimes it's turning it on, sometimes it's skipping. So this is the problem right now. This is the circuit that I built and that I used here. I put 2 capacitors here and this capacitor here that you can probably barely can see it, but it is there one. And are these 3 capacitors that you are seeing here, plus 1 resistor on this other side. That one, that resistor that is going directly there. It's a very minimalist circuit, but for all 3 buttons, because this rotation is actually a button in itself, turning off and then on again. So it's staying on all the time, and then is when I'm rotating the knob, it's turning off and then on again when it's reaching the other pad. So in essence, all is having 3 buttons. The third button is this pressing here, and A and B are these 2. So that's it. It's a very minimalistic, very nice circuit, but it turns out that is not that good. Like you see, I'm having this problem. This is not the first program that I burned this chip, this microcontroller with. I'm having the same behavior everywhere for every program that I start with. This is probably the 20th program that I put in it, and I was playing for a couple of days. Actually, it took me to reach on this conclusion that I am right now, and I believe is because of this circuit here is way too simplistic. I need a little bit more serious circuit. This is actually a button debouncing circuit, what I'm having here with all those capacitors and that resistor. And I actually copied, I find one circuit that I used in my past with other projects using a NOT gate 7414. It's a very small chip here with a single gate in it, and is doing and this is the circuit for it, and I know for sure is doing a very good job, very, very good job. So already this chip, what I'm having here, this microcontroller that I'm having it is working. It is receiving data from the knob and is transmitting some data to this RGB LED. I only coded, like I showed you the code, only the red LED, that's it for testing. So it is running, it is working, but interruptedly. And my biggest guess is because it's not having a very clear signal, on-off signal from these buttons. Each button that I'm having there are not debounced properly using those capacitors and this resistor in this formula that I'm having there is not good enough. So this is, I know for sure from experience, I know it that this is way more better than that simplistic modality. So that's the plan, that's the direction. This is the way. Yeah. Anyway, so I oscilloscope it, but I cannot understand what might be the cause. This is the morning, but last night when I was discussing about this subject, I thought of it. This is another point. I believe that this circuit is providing a dirty signal. That's why I'm seeing interrupted behavior or random behavior in the LED. And my hope is to have a very clean signal with this circuit here. That's all the point of switching from that circuit into this one, into this new one. I hope it's clearer now my intention, why I'm building it and for what reasons. I actually have a circuit with a NOT gate. This is with that very small chip that is having 5 pins. You cannot see it very well here. It will look funky, but this is a testing circuit. Okay, good enough. Or maybe I should make a test like this with this button and then link it to this potentiometer. Maybe. Yeah, it is still throwing errors for some reason. So it might not be the signal as I was thinking. This is still acting randomly. It is still doing a very funny business. And I know the signal that is coming from this circuit is very clean, very sharp, a very good signal. Motherfucker. So it's not the potentiometer, it is not this board, it's something else. Maybe it is programming. It might be. I'm not completely sure what the fuck is going on. Why is not responding to each press and why is acting randomly like that? And for sure it's not the links to the chip. I'm pretty sure it's because I did get some very good results other times in other experiments that I did with other codes when I was coding and sending the codes to the chip, to this RGB LED. I was getting consistent on and off, so it's not the chip. And I'm very sure it's not the microcontroller either. It's not like something is trembling there. I believe the code must be very, very special. But in what way it must be special, I have no idea. And I didn't test it. This is the first time when I'm using this rotary encoder button type. This is the first problems I'm having with it, and I have no idea what is the problem. You know what? I'm still having here on the negative. I'm thinking maybe that capacitor is adding some sort of interference. It's the only thing I can think of. So let me take it out and see if that capacitor is brand new, I know for sure. Or I did use some scrapped used capacitor there. I'm not completely sure. These capacitors are adding some sort of delay that is creating this randomness. It might be. Let me get rid of it. At least on that side. Actually on both sides. To be absolutely sure. They are very tiny capacitors there. I shouldn't get this randomness with this circuit. I shouldn't. And this might be a cause. A probable cause there. Alright. There is one. It's very tricky with these very small components. Here I'm having another capacitor as well. Maybe that's the problem. It might be. No, it didn't. So it's still random. Motherfucker. So now I have absolutely no connections to those capacitors. The only element that I'm having here in this circuit from the other circuit is one resistor. But that is limiting the current. It's not doing... It's very improbable that resistor is creating any type of randomness. Yeah, you see? I have to press multiple times here. Sometimes it's responsive, sometimes it's not responsive. So this is a big problem. So I'm bypassing that resistor. I'm connecting it directly to the ground there. No, I still have a random effect. Shit. I put that capacitor as a filter for interferences, but maybe it is creating some kind of interferences itself. And this is very tricky to take it out from here without destroying it. I really hope I can operate it. Yes. Have I destroyed it? One of its pins, or is intact? It's looking okay. Please work. No, it's still random. It is still random. Motherfucker. It is still random. Shit fuck. I really hoped it was one component like this. Either this or that, or the resistor. It should have been behaving like this. Like here. So to have the same behavior every time I'm pushing the button, doesn't matter what it's doing, to have the same behavior, that's what I'm after here. And it's not, it's still, sometimes it's on, sometimes it's off. That's not good. What can it be? What can it be, huh? The only thing I can think of, it is the programming. The code that I'm having inside the chip, I need to add some sort of debouncing maybe, or some sort of delay, or it worked very well, I believe. I don't remember how well it worked, actually, when I included a very large delay. When I was pressing once, I believe it was still having this randomness in the behavior. Very strange. So this means this circuit is not really helping with anything, so I will not make it. Although I prepared this integrated circuit here, I will put it back So now I'm putting it back here. I'll leave it here. And these three components that I took them out, I will leave them out for a while, and I will think about this problem, how to solve it. I do have this capacitor here on the power of this chip, on the power pins that is powering the chip. Maybe that is the fucker? I highly don't want to believe it is. Let's hope I can bend it out. So this was a surgical intervention, what I did here. It is still random. It's not that. No, it's still random. It's even more random now than before. It's probably more unstable. Maybe, you know what? Let me add a bigger capacitor on the input of the chip to filter it better. Yeah, I can add a 1 micro there, maybe. Yeah, 1 micro then, 1 microfarad. This is creating a large pool of energy. Theoretically, it should stabilize the chip very well, actually. No, it's still random. Yeah, I have to definitely change the code with a very, very basic code. A code for a button and not for a rotary encoder like I'm having right now. So right now I'm having a code for a rotary encoder. Let's go to programming realm and see if I can solve this problem. So I modified the code with this very, very basic code. This is a button, a very simple button code on off, and I changed it with whatever I'm having. Here is the actual source code that I copied from, and here is the behavior of it. That's the button. Let's see. You see how responsive it is? This is the normal behavior it should have. This is the expected behavior it should have from the beginning. So now, so you see, doesn't matter how slow. You see how slow I'm pressing the button, or how fast, is in synchronicity with it every time I'm pressing it. So yeah, definitely it didn't work with the red LED. I switched the LED with the green one and it's working perfectly. Let me actually switch it with the blue one. Okay, so now it's blue and it's exactly in synchronicity with my button press, what I'm having there. And you can see it is exactly as fast as I'm pressing here, which is excellent. Good, let's switch back to the red. I start to believe the red LED is the problem. So this is debugging the problem using code. Let's see if I'm still getting, no, it's still responsive. Wow. So I was having an internal error. Let me put back all the components as it was before. So in conclusion, the error was some sort of erroneous code inside the microcontroller that the compiler messed it up. Most probably it was. Like that. And it's very responsive right now as before. So it wasn't a hardware problem. It was strict a software one. Unbelievable. And not the software itself, but I don't think the code was bad, but I start to believe the compiler messed it up. Because I have a very strange arrangement here, that's why it's not like Arduino directly commanding this, Arduino Uno commanding this LED and that getting the signal from that button. Actually, let me wire back as it was not from that button. Yeah, okay. Because I did put the components back as they were. Let me put back this capacitor was 1 microfarad here, there, like that. And take out this and put this back. Yeah, even if it's very hot, I can very quickly not grab it, but touch it and move it very fast. Even if it was very hot. And now it's on. So this button helped me debug this problem actually very well, this debounced button. So this is a very good idea to have to check problems like this very strange one, very strange problem. I'm very unsure if the code was the actual problem. It might be the code, only the code itself, but I did see some strange errors I was getting because I'm sending through Arduino Uno R3 board. I'm sending the programming to program this one. So I got some strange errors from time to time, not all the time. And it was repeated. I was getting some repeated errors and consistent bad errors. That was the problem. That was the thing that put me to take out everything. It might be a coincidence between bad coding and compiler error. It might be like that in this particular case. That's why I'm not trusting anything. Yeah, okay. So this is consistent enough. I was getting this behavior at some point. I did get exactly this behavior when you see it's clearly pulsing per each knob turn. Yeah, I recognize this. I did in my many tests that I did. At some point I did this test and I get exactly this behavior, but I wasn't very sure about the other tests before, why they were not correct. But this is telling me this is the correct. So what I did here, I implemented a very simple and very basic button, on-off button press. And I basically link it to this rotary encoder. That's all that I did. A very extremely basic button press. And every time is doing a switch, pretty much a switch like this. We are back to this circuit again. So this and this, these are the two circuits. And actually it helped me very much because I trust it a lot. This is a very clean signal what I'm having here. And I'm trusting it a lot. This 7414 Schmidt trigger NOT gate. It's my favorite, but it's a bit too complex to make it. So this we are exactly back as in the beginning right now, and it is functioning correctly. And now I have the answer. So I'm getting erroneous compiling and have to be more careful with the code what I'm sending. So now it's performing excellent. You see how consistent it is per each turn. Is actually, you see how fast I'm turning, and it is very responsive, and also how slow I'm turning it. Yeah, you see I can keep it in between. Yeah, you see there, but it's turning back on every time. Doesn't matter how slow. So this is the slowest when I'm in between, and when I'm releasing it is moving automatically to back or forward, depends where I'm sitting with the in between part. So this is the correct behavior. This is what I wanted to see. This is a test. This is my debugging way of testing of this knob rotary encoder with this LED. So I'm testing it now this way, that later when I will implement the code for the numbers here to actually do the right thing with this LED, I can observe the problems very easily. So right now this is the debugging mode and error solving mode right now, and I learned my lesson. It's very good that I find an answer to the problem. Now I know what to do. I have to be more careful with the programming and not willy-nilly copy everything from internet. Because it is exactly what I did. I tried to cheat a little bit to get some code from somewhere else, because I never worked with this rotary encoder in my life. This is the first time when I'm using it and coding it. So definitely my first time. So I'm making stupid mistakes, and I wanted to actually get a workable code from somewhere else and use it in what I'm having here. But problems. And I have to think for myself what to do and how to make it work. That's the rule of the game. All right, see you later. And I didn't change anything drastically. I literally copied this function and I changed its name as 5 instead of 4, and I switched these two lines as high and low. So pretty much that is not correct anymore, and this is not correct anymore here. When this pin is getting a high, actually I can make it like this. Yeah, like this. This is a bit more simplified. The pin is high all the time actually, and is keeping the LED high, meaning is off. This is the LED off state, and this is on state of the LED. And when it's catching a low here, is sending a low signal to the LED and is turning it on, because my LED is inverse from the rest of the normal LEDs. So it's staying off all the time, is remaining off, but when I'm turning the knob, pick, and look how responsive it is, how fast, very fast I'm turning the knob, and how responsive that blip is getting, exactly the in between when it's jumping from one position to another position. And is very good, very responsive. This is what I wanted from the very beginning when I started this project. Well, this exercise with the potentiometer and the LED, this test, and I didn't get to this result what I'm having right now from the very beginning. I got a ton of errors, a ton of them. So this is perfect. This is perfect. Okay. And here I can get in between the positions of the knob, you see, and it's remaining on as long as I'm staying between the position. And if I'm letting it go, it's switching perfectly. So as slow as possible, you see, or as fast as possible. And I discovered a very stupid mistake, but not that drastic. I mean, I was wondering why the fuck this pressing button, when I'm pressing the button, that button is not working. And this is why. It is that I fucked up the circuit a little bit. I put this capacitor in line with the wire that is going to the negative. So the capacitor should have been between this pin and this pin. Exactly like this. Like here, not in line. Yeah, that's definitely a stupid mistake. Even I can make a stupid mistake like this. I did already this test. I tested already on Arduino board with the jumper wire. I tested it exactly like I will do it here. I changed the alligator clips because the cable was too thick and too stiff. So now when I'm pressing, only when I'm pressing the button, it should lit up. That's the only code that I put there. When I'm pressing the button, that LED should lit up. So if I'm bypassing this capacitor here, if I'm shorting it to actually leave the wire, that pin to the ground to go, if I'm pressing right now, it is actually doing the job. So that was a very stupid mistake. Well, it happens, and what is the most important thing is to catch the mistake and to repair them. This was not that critical mistake, but I did press this button a couple of times in all this experimentation until right now. This is what I should have do from the beginning. Okay, so this wire should get there, but it's not long enough. Okay, yeah, this is probably good enough. Yep, this is it. And now I have to power it. Now it should work correctly. It's actually doing the job. Very responsive, very good, excellent.